From the campus of the University of Nebraska at Omaha. Consider This, a program of issues and information behind today's news.
Hi everyone, I'm Kathy Wyatt. Welcome to the 25th season in this week's edition of Consider This. Our topic, climate change. Joining us to talk more about it is Beth Chalecki. Professor Chalecki is with UNO's Political Science Department. She has a background in international relations and environmental geography. Thank you so much for being here and welcome.
Thanks very much, Kathy, for having me back.
You bet.
Glad to be here.
I want to start by asking you to define climate change.
Climate change, as we're thinking of the phenomenon right now, climate change is anthropogenic global warming over and above naturally occurring levels. And what I mean by anthropogenic is that humans themselves are causing it. So as we can see from this graph here, the world is getting warmer. This time series runs from 1884 to 2020, courtesy of NASA, and they have measured, to their best ability, global surface temperature changes. Watch how it goes from blue to light yellow to red. As the world puts out more CO2 and other greenhouse gases, these are being trapped in the atmosphere and causing surface temperatures to rise. And by 2020, this is the highest they have ever been while humans have been living on the Earth.
And the impact is just unbelievable. We have three graphics that we want to put up for our viewers.
Yes.
We're going to start with this first one, Beth. Tell us what we are seeing here.
This first graph is showing you our best guesses as to what the Earth is going to look like at different levels of warming. Now, those top two Earths you see on this graphic, and these are courtesy of the Intergovernmental Panel on Climate Change. These are observed changes for 1 degree of global warming. Now, as the video just showed, we're at 1.1 already. So these are the temperature increases we have already seen, and the one on the far right at the top is what our models said we'd see. So that's a pretty good correlation, excepting that little blue spot off of Greenland, which is the result of Arctic ice melt off of the Greenland land mass into the North Atlantic Ocean. Our models are pretty good, and this gives us confidence that when we run the models forward, that what we're going to get is actually going to be a pretty close approximation of the different levels of warming we're going to see in the future. So if we are able to hold warming at the end of this coming century down to 1.5 degrees above industrial levels, that's the level we're going to see on the lower left. That's still pretty toasty. When you look at all of the warming over land, and particularly in the Arctic, you're still looking at quite a bit of additional temperature changes right there, mean temperature changes across those land masses, less across the ocean. At 2 degrees, you're seeing a significant increase. That's the land in the middle at the bottom. That's 2 degrees of warming. That's what we hope to achieve. We would like to be able to achieve 1.5, but our best hope right now is to hold it at 2 levels of warming. Even then, the Arctic is still 5.56 degrees centigrade warming, and if you look at North America, you can see that we are in for quite a bit of a heat increase. Increasingly, you'll see warming over rainforests and other ecologically important parts of the landmass, and Antarctica is starting to warm up as well, and that bodes ill for sea level rise, we'll talk about later. The one on the right, the lower right, is 4 degrees warming. That's off the charts, scary red Earth. And what that means is that's fossil fuel Earth. That's what happens if we don't curb our use of fossil fuels, reduce greenhouse gas emissions, and manage to sequester the ones we have, that we could actually reach that level of warming. Wow. Under that Earth, concepts like democracy and capitalism and individualism and so on, that might be completely off the table as to how society organizes itself. We could be full Mad Max by the time we get to that Earth at the lower right.
Okay, let's go to the next graphic and tell us what we are seeing there.
You are seeing these same three guesses, 1.5 degrees, 2 degrees, and 4 degrees. Mean precipitation changes. So the areas that are blue are going to see a greater change in precipitation, percent there on the bottom, and the areas that are brown, you're going to see less so. At 1.5, it's not that much of a change. But as you get higher, with higher levels of warming, now you begin to see precipitation changes that are to greater extremes. And by the time you get all the way to the right, fossil fuel Earth, you're looking at significant precipitation changes, both positive and negative, in key parts of the Earth. Look at that. Look at the Amazon rainforest in that last one. I mean, it's going to dry out considerably. Look at the Arctic. It's going to be considerably wetter. But overlay that in your mind with that last temperature graph I showed you, and it's falling there as rain and not snow, which means the Arctic Ocean is going to open up and absorb more heat. You can see how we would basically have to shift all of our agricultural patterns at this point, because we're used to certain steady levels of precipitation arriving at certain times in certain ways, and all bets are off under these levels of warming.
Okay, let's get into soil moisture then.
This is going to tell us where we might see greater drought. 1.5, 2, and 4 degrees again, maybe changes we can manage if you look at the Earth all the way to the left. We might be able to adapt to those levels of droughts and increasing soil moisture. But as you get farther to the right with increasing levels of warming, look at North America, look at where Nebraska is. We are an agricultural state here, and you can see how we might suffer significant levels of drought. We would have to reorder the country's economy entirely. And what scares me particularly about that last Earth is look at the Amazon rainforest. It's almost completely droughted out, if that's a word. I may have just invented that. But you can see there that the ecosystem that basically produces oxygen for the planet is severely compromised. Wow. So we have to bear all this in mind when we consider, is global warming real and what can we do about it?
We're going to talk about the human factor in just a minute, but I do want you to reiterate the causes. What are the culprits here?
The culprits of climate change is quite simple, actually. We continue to emit greenhouse gases into the atmosphere, and we don't pull enough of them out. When we start burning fossil fuels, coal, oil, and natural gas, all of these fantastic energy sources that have powered the Industrial Revolution, keep the lights on in the studio, and have given us such great lives, we can basically take that carbon out of the ground and put it up into the atmosphere. That's holding in more heat, just like that original video showed us. That's called the greenhouse effect. A little bit is fine. Too much, and we have a problem.
Okay, let's talk about this human factor. We have two things that we want to put up for our viewers. First, we'll show a video, and we're going to have you talk over that. And
sure.
Then we're going to go straight into a graphic just to try to become more aware of how we can make this worse or we could help make it better. So
Yes.
let's go ahead and put the video up first.
Okay.
Yeah.
So what this is showing us here is carbon dioxide levels going back 400,000 years before present times. And it's all been within a certain range up until roughly 1950, when it suddenly shoots up, and there's no other explanation for this that we can find other than what humans have caused. So if you look at that range, you can see natural cycles up and down over the period of tens of thousands and even hundreds of thousands of years until now. There's no way to explain what's happening here in this graph unless you account for what humans have caused, for what humans have put into the atmosphere.
Wow. Okay, and I want to put that graph up too that you had talked about.
Yes.
It kind of goes side by side with this.
Here we're looking at another finding recently from the IPCC, the report that they called the Red Flag for Humanity. And you can see what this is, change of global surface temperature as measured from 1850. So it recaptures a little bit of what we saw in that previous warming video where we saw the temperature increasing. Now, how do we know what causes this? There's natural factors that cause warming, and there's artificial factors that cause warming. And so from 1850 until about 1950, they overlap pretty much, which means at that point you can't separate them. But right around 1950, 1960, 1970, we start to see these two paths diverge. So you have the blue path down there at the bottom, which is only natural causes of warming, only natural sources of greenhouse gases, like volcanic eruptions and so on. If you add in what humans do, burning gas in your car, using gas to heat your home, burning oil and so on, add those in and you see that pink path is going up like this, right? Mm-hmm. It's creating greater levels of warming. Now, when it says observed there, you can see that is actual temperature readings. Remember, this is all in the past. This isn't a computer model. So we're actually comparing this with temperature readings we've taken since 1850. they all fall in the pink zone. What this means is there's no way to account for reality unless you include what humans have done. There's no way to say this is just a natural phenomenon, this happens all the time, humans aren't causing this. We have evidence that humans are causing this. We can see exactly what we've done here.
And what do you say to people, Beth, who are, we're all living here in the moment and we're saying, oh, it's just a little warmer, it's just a little this, it's not really that big of a deal right now. How do you address that with people?
I would say, I see what they're saying, 1.1 degrees, so what? It doesn't seem like a big deal. And it's not to you or me. We can put on a t-shirt or take off a sweater or do whatever. But to an ecosystem, a degree and a half, 2 degrees sustained warming is huge because they've evolved under certain steady conditions. And to change that suddenly over a really short period of time, as we've done in ecological time periods, that's pretty short what we did, then they have to adapt quickly or die. And so what's going to happen is all of the environmental assumptions that we've rested our economy and our society and our culture on are going to be shifting, and we have to shift with it. So 1 or 2 degrees warming could be catastrophic if we don't address it properly.
Okay, let's talk about strategies that have been used to try to address this problem too, right? Mitigation and adaptation, right?
Yes.
Talk about those two strategies. Well, let's just introduce those first.
Mitigation is basically trying to cut greenhouse gas emissions. This is when you try to stop emitting so much. We have tried this from a top-down measure with the Kyoto Protocol, when the UN basically assigned various developing countries a target that they had to meet to cut their emissions. Countries weren't interested in doing it. We'll talk about that in a bit. We've tried a bottom-up approach with the Paris Agreement. Instead of having the UN top-down say, you will cut this much, you will cut this much, they went to all the countries and they say, okay, you tell us what you're willing to do. Bring your own climate plan to the table, and we will add all those together, and that will be the Paris Agreement. But it doesn't get us all the way where we need to go. Eventually, what it comes down to is all of these measures together. Mitigation, adaptation, which is trying to adapt to these changes that we're bringing about, the changes in soil moisture and precipitation and temperature, sea level rise, which we didn't see, and all the other secondary effects that come from this. And the third option, which we're going to talk about, potentially geoengineering.
Yeah, and I mean, what you're describing there sounds great in theory, but you also have to assume that your world leaders are going to come together, that your communities are going to come together. And hasn't that kind of been the big stumbling block, as you've described, is getting people to unite and then to collaborate and work together?
We would love to be able to assume that our leaders will come together and recognize the problem. Unfortunately, if they've recognized the problem, they're not willing to act together. And I think the reason is that nations don't want to be the first ones to go to do this. The entire global economy runs on fossil fuels. We're slowly starting to transition parts of it, like electricity production and so on, over to non-carbon energy sources. But transportation fuel and other methods of energy, other methods of travel, we don't have good substitutes for yet. So no country wants to be the one to go first, because that means that they're going to do all the heavy lifting. It's like a free rider problem is the term I'm searching for. What it means is that every country wants other countries to go first. Everybody gets the benefit, but only certain countries would pay the price. So everybody's waiting for someone else to go first. And that's what's been slowing us down. There's also an issue as well of carbon and carbon-based energy powering development. When we look at the wealthy countries in the world, the United States, Europe, Australia, Japan, they are the ones that got rich and developed based on fossil fuels. And so other countries now that are coming up to development, China, India, Brazil, South Africa, these countries also want to develop. They want to get wealthy, they want to have good lives for their people, they have every right to want this. We're saying if you do this with fossil fuels, you're going to crash the whole climate. But they think that they have the right to do this as we did. And so there's a global carbon justice issue at stake here that the developing countries want to say, all right, developed world, you go first, and we'll follow you when we're as rich as you are. So this has been a stumbling block at all levels of international negotiation.
Wow. Okay, we are going to talk about that third option that you mentioned, geoengineering. But before we get into that, I think it would be important for our viewers to know a little bit more about you. You're obviously very passionate about this. This is your life, right? Tell us a little bit about you.
When I talk to my friends and colleagues about climate change, I always say, welcome to my life, as though this weren't their lives too, which it is. I've been interested in security for my whole academic career. I was very interested in security. And back when I was in undergrad, there was still the Soviet Union and nuclear weapons were a big concern. Less so now, although they still are a concern. But I was on a trade trip to the former Soviet Union, and I saw in their pursuit of nuclear weapons what they did to their environment to get it. And I thought to myself, you can't have any kind of security if you don't protect the environment. And it was on this trip that I realized this, and I became an environmentalist. So as I came back from this trade trip, I realized I needed to know more about this. So I pursued environmental geography and other types of environment, climate knowledge, and so on that would lead me down this path to think, how would we find security for everybody, not just one nation or one people or one hemisphere or one class of nations like developing countries? How does everybody get security? And it rests on a stable climate. So since then, I've been pursuing this path, and it's fascinating and a little scary.
How many of you are there? Because it seems to me, with your background in the international realm and so forth, that there can't be too many people with your degree of knowledge, or maybe I'm wrong.
I'm the only one in Nebraska, that's true.
Yeah.
But there are other colleagues, like-minded colleagues, and we get together at conferences and such and put our minds together on this, yes.
I was going to ask
yes.
how you collaborated and with whom. Are we talking about people from all around, representation?
A lot of academics are interested in these connections now, yes. You also see a lot of what I fondly call policy wonks, because I used to be one of them, who are interested in this on the security side, on the climate side. They understand why we need to connect with one another, because no country is going to be able to deal with this problem on their own. No sector of the economy is going to fix this individually. So we have to bring everybody's brain to bear on this problem. And for the security perspective, that can often motivate a lot of people. They are very interested in knowing how we can make our country more secure. They think of weapons, and they think of tanks and armies and so on. Increasingly, they think of cyber attacks. I'm saying we need to think about the climate, because if you don't have that, then everything else you do is going to be just, whistling in the wind.
Yeah, as you're talking, I'm trying to think about what a meeting involving your colleagues would be like, knowing what you know, not just today, but what could happen if people really don't wake up to this issue. Can you talk a little bit about that in terms of being really forced to think further outside the box than normal, right? To convince people.
We all certainly feel like we have pushing a rock up a hill to some degree. A lot of folks don't want to hear about this. They just think the problem is too far in the future, that humans aren't causing it. A senator stood on the floor of the Senate and said that God would save us. I mean, perhaps that's true, I don't know, but I don't want to bank on that as a policy. This is the sort of thing where you have to go out of your way all the time to be a climate persuader. You need to remind people all the time about what they're doing and about the best ways to tackle this problem, and that it will take all of us. And so often we see depictions of the negative effects. I mean, the graphs we just looked at, we saw how the world was going to get hotter and how it was going to get drier in some places and wetter in others, and there was going to be a drought here and so on. What would the world look like if we were able to stabilize climate emissions and we were able to actually invest sustainability in development, so that development was green and pedestrian friendly and human friendly and didn't upset the ecosystem and didn't perturb agriculture and so on? I mean, that's where we're going towards. What we're trying to get away from with the idea of the climate, anthropogenic climate change, is this idea of the world we want to avoid this. We want to avoid this level of warming. But that's often not enough of a motivator for people. They feel very fatalistic about it. And so instead, I'm saying, well, all right, let's, and I ask your viewers to do this too. Let's say, what world do you want to see? What's the world you want to go toward, and not the world you want to flee from? Because that's what's going to motivate people to do it.
Well, yeah, I was going to ask you, as you were describing that, we think about our kids, our grandkids, our great-grandkids. This may not be as much about us right now in terms of the impact, but it is going to be about somebody that we care about. So let's go into the future, Beth. Let's say not much is done. Let's say that we continue status quo. How many years are we talking before we really start to seriously feel this change?
That is going to be a tricky question, because it depends on how you mean seriously feel. The IPCC gave us about a decade to begin to bend that carbon emissions curve downward. If we don't start turning it around at that point, then we're baked into some real serious changes, some heat waves, droughts, sea level rise, increasing levels of disease, increasing mosquitoes everywhere, and so on. This is what we're trying to avoid. So you mentioned the children and the grandchildren and the great-grandchildren. Think about what your great-grandparents left for you. They left you a clean, stable environment in most cases. They planted trees so you would enjoy them. Now we have to do the same, metaphorically and literally, planting trees, but also metaphorically. We need to take care of this environment now and restore it back to its stable state that we enjoyed for our grandkids. So when they are our age, they don't look back at us and say, what on earth were you thinking?
Right. Geoengineering, another option, another strategy.
Yes.
What is that?
Geoengineering, this is highly contested at the moment. This is not something that I think we need to rush into. Geoengineering basically is artificial manipulation of the climate using technology, and there's two main ways to do that. The term geoengineering is very broad, and it encompasses a number of technologies, but there's two main types of technologies. The first one is called solar radiation management, or solar geo for short, and this involves bouncing sunlight out of the atmosphere before it has a chance to reach the Earth. If you remember the greenhouse effect, the sunlight comes down, reaches the Earth, and then is radiated as infrared heat. What we're trying to do with solar geo, or what solar geoengineers are trying to do, is bounce that out before it has a chance to reach the Earth. So shading the Earth to some degree from sunlight. And there's various ways to do that. The other main method is called carbon dioxide removal, and is literally just sucking CO2 straight out of the air and sequestering it somewhere, underground or in some other way. And this would involve longer time horizons. Solar geo we could do over a relatively short period of time. CDR would take longer to do, but it's ecologically safer, basically. You're taking CO2, you're taking the gases we emitted and just taking them back out of the air and sequestering them underground. You got the fossil fuels from underground, put the carbon in the air, now we're taking the carbon out and putting it back underground. I think this is a very promising approach. That's going to take time to do, but it's very promising. Solar geo, a little scarier.
But aren't you still going to have that buy-in from your leaders and that collaborative effort? And so how would this be perceived as anything different to them? It's still going to take an effort, right?
It's still going to take an effort, and it's still going to take time and money, and that's of course something nations are very parsimonious about. But I think that this could be seen as a good intermediary step, because it will buy us some time if we can do this. It will buy us some decades, if we're serious about pulling CO2 out of the air, to develop non-carbon sources of energy. We're not giving up energy anytime soon. What we need to do is take the carbon out of it, develop something that would replace the internal combustion engine, so we didn't have to use carbon-based fuels in order to power transport and so on. Carbon dioxide removal might be a way to do that. And if nations could see a profit in developing that kinds of technology, they might be motivated to do it.
Timeline, what would you be looking at if they were?
Oh, you're talking about decades, which we don't have decades because the IPCC has given us 10 years. So you're talking maybe 30, 40, 50 years. The intermediate step that a lot of scientists have proposed, I shouldn't say a lot, some scientists have proposed, is the solar geo step. And there's various ways to do that. By the simplest one would be shading the atmosphere with sulfur dioxide particles in the atmosphere. So you would send up a plane and you would basically spew what would be basically an artificial volcanic eruption minus the eruption. You take all that dust, you put it up in the atmosphere, and it shades the planet for a certain period of time. Problem with this is that if you use sulfur, it rains out as acid rain, oops, and it's going to precipitate out anyway in about a year, so you have to keep doing it. You have to keep putting it up there. And in the meantime, if you're not taking greenhouse gases out while you're doing this, in other words, if you're not pursuing both of these arms of geoengineering technology simultaneously, then if you stop the sunshade, what happens is the air has been accumulating greenhouse gases. You've been putting more and more in there, so when sunlight finally does come back down through, the temperature's going to spike. It's called the termination effect, and that will have a sudden shock to most of the ecosystems on the planet, ocean and land. So it's very tricky and very problematic.
Yeah, it'd be very interesting to keep our eyes
on
this whole thing. We have just a couple minutes remaining. I did want to ask you the impact of the pandemic on this particular topic. Is there any kind of...
The pandemic didn't even put a dent in carbon emissions. So I think we need to keep our eye on the prize here. We need to keep thinking the pandemic will be over shortly, hopefully, knock on wood, right? And that the pandemic hasn't relieved us of this problem at all. Our responsibility for dealing with this problem remains. So if we are going to embrace mitigation, adaptation, and potentially geoengineering, we need to get out ahead of this problem. We can't hide behind a pandemic or anything else. We have to keep our focus on this climate problem, this climate crisis that we've put ourselves into, and figure out ways to get ourselves out of it, and soon.
I want to spend the last 2 minutes, minute and a half, 2 minutes, talking just practical things that Nebraskans can be doing to make a dent.
Okay, what we can do is drive less. Anytime you're using an internal combustion engine, you are contributing to the problem in a big way and a little way. Drive less, fly less. I hate Zoom as much as anybody now at the end of the pandemic, but sometimes, it can serve its purpose. We can certainly push our energy providers to go carbon-free. OPPD is doing a great job of this. In their residential energy, they're doing a fantastic job of sourcing from renewable energy generation points. We need to pressure all utilities to do that. Certainly eating less meat is a good way to cut down on climate change. And the best thing you can do, all the viewers should know this, the absolute best thing you can do is vote. Too many people pretend that it's just, I'll just put in a squiggly light bulb, my contribution is done. And in the meantime, in Washington, who knows what they're doing. This is the biggest contribution that we as citizens, as Nebraskans, as Americans, as human beings can make, is to vote for leadership that takes this problem seriously and presents a concrete plan as to how they're going to ameliorate it. Don't let any elected official, a mayor or a representative, a governor, a senator, a president, hide behind some plan like, oh, well, we'll get to that in the future, or I have some people are studying this, technology will save us, so on and so forth. Don't believe it. We need to vote for those people who have got a plan on the table now, and we all need to pitch in and recognize that what world we're leaving to our grandchildren if we don't do this.
Thank you. We're talking with Professor Beth Chalecki today about climate change. I want to thank you for sharing your time and expertise and put up a graphic. You bet. We want to put up a graphic for our viewers in the event that they want to learn more. EPA.gov, NOAA.gov, IPCC.ch.
Yep.
Yeah. Beth, thank you so much.
You're very
Best
welcome.
wishes to you. We'll
Thank
keep
you.
our eyes and ears open to this issue.
I hope so.
Yeah.
Don't forget to vote.
Yes, thank you. Thanks to the students who are working so hard behind the scenes, and of course all of you for watching. As we close, a look at the Benson District in Omaha as seen through the lens of Pauline Dulang, a junior here at UNO.
Consider This is an issues and information program produced by UNO Television. More information and program archives can be found at nebraskapublicmedia.org/considerthis. If you'd like to share your comments about this program, call UNO Television at 402-554-2516 during regular business hours, or send an email to cwyatt@unomaha.edu.